Hello friends, good morning. So in this lecture we are going to discuss about classification of fluid. As you can see in this diagram is versus sorry, this diagram is shear stress versus velocity gradient. So actually the as per the Newtonian law of motion, the equation is tau means shear stress is equals to mu du by dy. Mu means dynamic viscosity, du by dy means velocity gradient, where du represent change in velocity and dy represent with respect to the thickness of the fluid. Okay, so there are certain number of classification as mentioned here. So the first classification is ideal fluid, second is real fluid, where it is written ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. So as you can see, it is very much easy to define each and every particular fluid. So how to define it? Let's discuss it in detail. So Newtonian fluid means which follows the Newton's law of viscosity. Tau is equals to mu du by dy. Non-Newtonian fluid means which does not follow the Newton's law of viscosity. Correct? So this two classification is very much clear. Now ideal fluid means which does not have any thickness, and such kind of fluid is also not possible. Ideal solid means it's a complete solid, it can't flow, so that is called solid. Okay, and ideal plastic fluid which follows the Newtonian's law but after application of certain amount of shear stress. So that is the definition of ideal plastic fluids. Now there are certain types of fluid which are considered under the non-Newtonian fluid, like blood, like milk. So these are the non-Newtonian fluid, like paste of the toothpaste. So that these are the examples of non-Newtonian fluid, and there are certain category into it. So let's discuss it in detail. Okay, I am sharing this file with you on a My Class Campus app, so you can check out the complete details over there. But if you are having any doubt, you can ask me in a comment section. I will try my level best to solve it. Okay, so which the fluid which does not follows the Newton's law of viscosity it is called non-Newtonian fluid. Correct? That is the definition of the non-Newtonian fluid. So there are two category into it. One is time dependent, time independent, and another one is time dependent. So under the time independent, there are three categories of fluid. Non-Newtonian fluid, we are discussing right now about non-Newtonian fluid. Pseudoplastic, dilatant fluid, and third one is ideal Bingham fluid. And the fluid which is time dependent, it is thixotropic and rheotropic. So these are the subcategories of the non-Newtonian fluid. Just check out this figure, this graph, in order to understand in a depth manner what do you mean by non-Newtonian fluid. So non-Newtonian fluid can be defined from the Newtonian fluid. So Newtonian fluid is here. Correct? Newtonian fluid or ideal plastic fluid, which we have already discussed, that is ideal Bingham or ideal plastic fluid. These are the fluids which is from the previous diagram as well. These are mentioned in the previous diagram as well. So when the n proportion tau is equals to mu du by dy, but if the du by dy having some degree on it, and if it is degree is greater than 1, then it is called dilatant fluid. If the degree is less than 1, then it is called pseudoplastic fluid. If the degree of the ideal plastic that is greater than 1, then it is called rheotropic fluid, and if it is less than 1, then it is called thixotropic fluid. So these are the examples of the non-Newtonian fluid. Let's discuss it in detail, because it is not as much simple as it looks. correct? So first let's discuss about the time independent fluid, in which first pseudoplastic will be there. Pseudoplastic is the higher velocity gradient where the shearing force increases less than proportionally, correct? So that what we have discussed here. The phenomena of under the influence of moment, the liquid seems to become thinner. Subsequently it is known as shear diminishing. So what happens, as the velocity gradient increases, the liquid become thinner and thinner. So that is the particular characteristics of the pseudoplastic fluid. And pseudoplastic fluid examples are blood, milk, etc. So if after attending this lecture, if someone asks you that blood is which kind of fluid, then what would be your answer? The answer is, sir, the blood is pseudoplastic type of fluid in which it does not follow the Newton's law of viscosity, hence it is called non-Newtonian fluid. The second fluid, time dependent, is dilatant fluid. The dilatant fluid is, in dilatant, the viscosity of fluids will grow with the rate of shear strain, hence n greater than 1. So shear strain degree is more than 1. It is additionally termed as shear thickening. For example, butter solution, sugar solution, reach start solution. So from the examples you are able to visualize the theorem that as the butter solution flows, the thickness is going to be increased. So that's why it is called dilatant fluid. So butter solution is the example of the dilatant fluid under non-Newtonian fluid, correct? And ideal Bingham fluid, it has some underlying quality past which mishappening begins. For example, toothpaste, cream, sewage, sludge, etc. So toothpaste, creams, sewage, sludge, so these are the type of fluid. Which type of fluid? It is called ideal Bingham type of fluid, correct? Now there are two categories of time dependent. One is thixotropic and another one is rheotropic. Thixotropic example is paint, printing. So these are the examples of the thixotropic material. In a thixotropic fluid, which takes a finite time to attain equilibrium viscosity when introduced to the steep change shear rate, it will take finite time to attain equilibrium. Equilibrium means in order to stabilize. They are reversible changes from fluid to solid, like elastic gel. So here the crack is mentioned here. In case of thixotropic material, it can be solidified after a certain period of time, or it cannot flow after a certain period of time, like paint. If we paint the wall with a paint color, then after a certain period of time the paint color cannot come out from the wall. So that kind of property, if any fluid derived, then it is called thixotropic type of fluid under non-Newtonian fluid, and again time dependent as well. Means after certain period of time it will not persist or persevering the property of the liquid or fluid. Okay, rheotropic fluid, rheopatic fluid. So rheopatic fluid, mu increases with the time for which shearing force are applied. Here n is greater than 1, B is not equals to 0. Example, gypsum paste and bentonite solution. So bentonite solutions are rheotopic type of fluid. So in rheotopic type of fluid also, after certain period of time it becomes solidify, like the bentonite solution used in the cosmetic. So after putting into skin, it will be solidified. Okay. The ideal plastic fluid, the fluid in which shear stress is more than the yield value and the shear stress is proportional to the rate of shear strain or velocity gradient, is known as ideal plastic fluid. So after applying certain amount of shear force, if any fluid behaves like a Newtonian fluid, then it is called ideal plastic fluid. So these are the classification of the fluids. I hope you enjoyed this video. Write down as an exam, as an assignment, and submit it to me personally on my WhatsApp number. Thank you.